Okay, we're going to look at infinite limits. Infinite limits we've actually talked about before. Infinite limits are going to describe the behavior of the graph near a vertical asymptote. Vertical asymptote. Sorry, I spelled vertical wrong there. Okay, so this is the graph of f of x. The limit as x approaches 3 from the positive, and the limit as x approaches 3 from the negative side. First, let me look at x equals 3. At x equals 3, there's actually an asymptote. So I'm trying to figure out on either side of the asymptote, what is the graph doing, or what are the y values of the graph doing? Okay, so the first one asks me, limit as x approaches 3 from the positive side. So the positive side is on the right side. So on the right side of the asymptote, what's my graph doing? My graph is going up. It's going up forever. So on the right side of x equals 3, the limit as x approaches 3 from the positive side is positive infinity or just infinity. Okay, now the limit as x approaches 3 from the negative side. The negative side of x equals 3 is the left side. So if I follow the graph on the left side of the asymptote, it's also going up forever. Okay, because it's going up forever, the limit as x approaches 3 from the negative side is also infinity. Okay, because the left and right side limits are the same, it is also possible for me to see the limit as x approaches 3 of f of x is equal to infinity. And if you look at the graph, that makes sense because x approaches 3 from either side, the graph is going to go up. Okay, now let's look at a different asymptote. This is saying the limit as x approaches -9 from the positive side and the limit as x approaches -9 from the negative side. So x equals -9 is over here, and I can see that it's an asymptote. So on either side of the asymptote, I want to be able to explain what the graph is doing. Okay, so first the limit as x approaches -9 from the positive side is the right side of the asymptote. So on the right side of the asymptote, this graph is actually going down. It's going down forever. So this is going to be negative infinity. Why don't my colors ever do what I want them to do? Okay, now the limit as x approaches -9 from the negative side is going to be on the left side of the asymptote. So on the left side of x equals -9, the graph is going up forever. So in that case, the limit is going to be positive infinity. Okay, so this is a good way to describe on the right side of the asymptote, the graph goes down. On the left side of the asymptote, the graph goes up. Because the left and right sides of the asymptote are not doing the same behavior, the limit as x approaches -9 of this graph does not exist. And that's because the behaviors don't match. Does not exist. Okay, for these next ones, I'm given an equation and I'm going to describe the behavior at the graph around the vertical asymptotes, but I just don't have the graph, so I'm going to use the equation to figure out the behavior. So use one-sided limits to describe the behavior of the graph at x equals 3, and if I look at this equation, I can tell that there will be an asymptote at x equals 3. So on either side of the asymptote, I'm trying to see is the graph going to go up or down? It doesn't matter which one you do first. Let's do 3 from the positive side for no particular reason. Okay, I'm going to plug 3 from the positive side into the graph, even though 3 from the positive side is really just 3, just approaching it from one side or the other. Okay, so if I approach 3 from the positive side, okay, if I approach 3 from the positive side and I subtract 3, I'm going to get 0 from the positive side. Now there's no such thing as positive 0, so this is still just 0, but I'm approaching it from the positive side. Why does this make a difference? Because if I do 5 divided by 0 from the positive side, I'm going to get positive infinity. If you have 5 cookies and you divide it by, no, you can't. Ask Siri why 5 divided by 0 is infinity. Okay, 5 divided by 0 from the positive side is positive infinity. So on the right side of the x equals 3 asymptote, the graph is going to increase. Now on the left side, so x approaches 3 from the left side of the graph. I'm approaching 3 from the negative side and I'm subtracting 3. This is not, 3 from the negative side is 3, but I'm coming at it from the negative side. So I'm coming at it from the 2.99999 side. So if I do 2.99999 minus 3, I get 0, but it's coming from the negative side. If I do 5 divided by 0 from the negative side, I get negative infinity. Okay, and yes, I know there's no such thing as negative 0, so that's why we're just saying we're approaching 0 from the negative side. Okay, let's look at another function and the asymptote. So g of x is 5x over x plus 2 squared. There is an asymptote at x equals negative 2. So we're just going to look at the behavior of the graph on either side of the asymptote. So on the right side of the asymptote, let's see, 5 times negative 2. I can put from the positive side, but it's not going to change anything in that particular expression. Negative 2 from the positive side plus 2, and then I square it. I get negative 10. Negative 2 on the positive side of negative 2 is approaching from the negative 1.99999 side. So negative 1.999 plus 2 is 0.0000, a teeny bit positive. Not really, though. Just approaching 0 from the positive side. So I'm going to negative 10 over 0 from the positive squared is going to still be 0 from the positive, even though there's no such thing as positive 0. So I'm going to get negative infinity. So the graph's going down on the right side. On the left side of x equals negative 2. The negative side of negative 2 would be approaching from the negative 0.200001 side. Negative 2.0001 plus 2 is going to be negative 0.00000, which is still 0, but it's 0 from the negative side. Although once I square it, it becomes, I don't want to say positive 0, it just becomes, I don't know. Let's put negative infinity here. Okay, so on both sides of the asymptote, the graph is going down. So I could even say the limit as x approaches negative 2 of g of x is negative infinity, and that would be a good way to describe the behavior on both sides of the asymptote. Let's do one more weird one. Okay, last one's let h of x equal 2x over 3 times the sine of x minus 1. Describe the end behavior at the graph at x equals 1. If I plug in x equals 1, I get 3 times the sine of 0, which gives me a 0 in the denominator. So this would produce an asymptote. Even though we have not graphed this function before, we can still figure out the behavior. Okay, let's start from the right side. Okay, now if I want to do sine of 0, I know it's going to be 0, but is it 0 from the positive side or 0 from the negative side? Let's contemplate this picture. Okay, I'm going to approach 0 from the positive side of the unit circle. So the positive would be where like the positive pi over 6 is. So from pi over 6, I'm going to go towards 0. Okay, which means my y value is going to be 0, but it's approaching it from the positive side because I'm coming from quadrant 1 as I come down. So this is going to be 3 times 0 from the positive side, which is 0 from the positive side, which is going to give me a positive infinity. Okay, now let's approach the graph or the asymptote from the left side. So I approach 1 from the negative side. If I do 1 from the negative side minus 1, think it's like 0.99999 minus 1, which is going to be not slightly negative, but 0 from the negative side. Okay, now if I do sine of 0 coming from the negative side, I'm going to approach 0 on the unit circle from the negative side. So from negative pi over 6 or something like that. So from quadrant 4, I'm going to go up and approach the 0. Because I'm coming from where the y's are negative, I'm approaching 0 from the negative side. So the behavior of the graph is it's going to go down on the left side of x equals 1. If you want to graph this, you could always graph it in Desmos and then make sure that the behavior on the right side goes up, behavior on the left side of the asymptote goes down.